Today, in episode 7 of the ISP series, we're wrangling the total control and getting this beast configured for the dial-up ISP. Along the way, we'll learn about T1 PRI and talk to Bryan Wann about his experiences operating a homegrown ISP. And with any luck, get the total control online and accepting calls. In our first Total Control video, we learned about its capability as an all-in-one box, combining the features of a terminal server with dozens of digital modems. And we were inundated with your stories about using the Total Control platform in the 90s, and we even received copies of the original management software and firmware. And check this out, we got pictures from a viewer showing fully populated Total Controls that were only just removed from service earlier this year. But now that we've achieved our goal of getting the total control actually running, we can start the hard part, getting it configured for our dial-up ISP. But before getting started, we wanted to get some first-hand knowledge of managing and supporting these units. And that's when we came across the USR-TC mailing list. Back in 1997, a USR engineer, Tatai Krishnan, who goes by Krish, was often responding to messages on the list. We were actually able to track him down, and he was kind enough to chat with us.
I was the one who actually built that particular mailing list.
Krish first told us how the total control evolved into the one we have today.
In late 92s and early 93, we started coming up with the V34, and we came with the NMC. Now we had a router card. The router card basically was called net server. The net server would actually establish a PPP session for you. So in this particular case, you don't have cables hanging over or anything else. The chassis backplane would actually be the plane that would actually communicate to the net server. The net server had a limit. I think it was the initial one was like 48 ports, 24 or 48 ports. So users would connect, they would establish PPP sessions, and the net server would take a TCP Ethernet or a token ring connection and connect back to the network, and then they would establish all the connections to whichever host that you wanted. And AOL was one of the largest consumers. Sprint, Prodigy, CompuServe, Mindspring, quite a few of Centennial. There were quite a few ISPs who would just use that. They would have racks of these modems that would actually allow them to connect.
There was this long thing where someone kind of rallied all the ISPs and wrote a letter to like the 3Com product manager or somebody with like, here's the top 10 problems we have with total control. At the end, we're like, I know we're complaining a lot, but we really love the total control, but it has these problems. For reading these old messages, and this is all from like the smaller mom and pop ISPs, it's kind of crazy to think that there were huge ISPs not talking on the mailing list. Did the big ISPs have the same problems as the small ISPs, or were they handled differently from the software they were running or how they were managed?
They had problems with AOL, they had problems with Sprint, we had problems with the bigger ISPs also. But their technology and their ways of using the net server was pretty standardized. In a sense, it had, like AOL, for example, had a very decent way of managing their platform. They built their own SNMP solution that would go and look at what is happening, and they would take the syslog, they would parse the syslog, and based on the syslog, they would know which particular modem is good or bad, and they would go and reset it automatically. And the larger ISPs never really took the latest code and deployed it. Going forward, when ISDN came in, we actually started moving into ISDN and provide you 128K connectivity. From there, slowly we went into cable modem, which did not become a big hit. The total control life, I think, came to a decent end. But from a US robotics perspective, our modem code was one of the best. It surpassed every modem stuff, right? So we had the best modems, we had the best things, technologies going forward.
It was eye-opening talking with Krish to get the perspective of the vendor side during the dial-up ISP era. but we also wanted to hear from the ISP side firsthand. And fortunately, the Serial Port Discord server is chock full of knowledge and experience. One of our supporters, Bryan Wann, owned and operated an ISP in Oklahoma starting in 1996 when he was still just a high school student.
Mom was answering the phones. And like when I come back from class, I'd like call everyone back, like, hey, here's how to set up your stuff. I started in 96 and I finally sold it off in 2004. But like, as soon as I got started, within like 2 years, like I had to upgrade from 28K to 33K modems. And then by 98, I was having to roll out V.90 everywhere. So I'd like scrap everything by digital. And then like 2000 rolled around. I started like selling DSL and everything. So it was just like wham, 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 wham. It's just crazy cow expensive.
Wann started CompuWare Internet Services with just a single point of presence in Stigler, Oklahoma.
So like originally I started off doing like call forwarding a bunch of cities into my location. Then like Southwestern Bell yanked our calling plan because like they said we were abusing it. So then I had to go actually like build POPs. Basically each POP was like a Portmaster 2 ER with a rack of modems. And then I was using frame relay to haul back to the office. I think in the end I had seven actual POPs in the field. I had rented a office in the town, or like in the county seat, which had like a population of 2,000 people. So that gave me my initial foothold there. We started renting an office there, and then like we were losing money. So like me and Dad like built a little kind of like portable building. We rented a lot for like $100, and like, hey, we want to build a building on it. Sure, fine, go ahead. So like we went there, we built a building on it. We moved everything there, and ran it from there ever since. But yeah, I had like 2 racks full of gear, all the dial-up servers, did like everything out of there. So originally I bought I think it was a Hayes Optima modem rack. I got like the SysOp discount that was going around, like, oh, this is sweet, it's beautiful chassis. Hooked it up and like no one could connect to it. And like, what's going on? They're supposed to be like the top of the line modems. So I was complaining about it to my upstream ISP, and he's like, no, use Boca modems. Like, I never even heard of them. So I bought a little Boca modem rack, had like 16 modems in it. And those things were beautiful, like everyone could connect to them.
Eventually, though, the ISP grew large enough that Wann needed to go digital, but not with US Robotics at first.
I didn't have a good impression of 3Com or US Robotics at the time. Like, I don't know, they were like spammy or had aggressive salesperson or something. And like they turned me off. It turned a lot of people in the ISP world off. And so like, I just kind of like slammed the door on them. And like I stayed with Livingston or Lucent. And that's how I went up going with the PM3 for 56K rather than USRs. And then I found out that like I had the same problems all over again. Like no one could connect to the PM3s. I was like losing customers left and right. I was like, okay, maybe I think I evaled like a Cisco 5200 and evaled a total control rack. I'm like, hey, everyone can connect to the total control. I'll start buying those things now.
I think you were telling me you would have different access numbers for the PM3 versus total control, so people could switch between them.
Yeah, I usually had like the bulk of the hunt, or the majority of the hunt group was going to the USR, and then I had like maybe like one T1 going to the Portmaster 3, and so they had different numbers, but they rolled over into each other. So like if the Portmaster was full, it rolled over in the total control. Or if the total control, it rolled over to the Portmaster. So like trying to stretch things out as much as possible.
Were there any downsides of the total control?
They were a little bit more expensive than the Portmasters, but like technically they are a great chassis. Other than being like ridiculously loud and heavy, I can't really think of any downsides to them. They were pretty rock solid. I only had like one card failure, like it just died, and I had to like go to Texas and borrow a spare card from a buddy to get my POP back up online. That was the only problem I had with them.
But like all dial-up ISPs, it wouldn't last forever. Wann's ISP would persist until 2004 when he sold the company and split his customers between Tulsa Connect and FullNet. We were inspired by his story though, and before we signed off, he asked an important question.
Have any idea what you're going to use for like digital phone lines going into it or anything?
And in fact, we had. While we've already set up a T1 feed for our ISP's connection to the internet, the existing telephone infrastructure we've been working with so far consists of analog lines through voice over IP, and that won't work for the total control. Not only do the modem cards lack RJ11 jacks in the first place, but can you imagine trying to connect 48 separate phone lines to this single chassis? Instead of individual phone lines, most ISPs had T1s carrying the incoming calls, and on the total control, these are connected through the dual T1 DS1 NIC. And ISPs would have had two choices for incoming calls: a voice T1 or something called a PRI or primary rate interface. A voice T1 is so called because it carries audio signals from telephone or modem calls. And like we described in episode 3, there are 24 channels or time slots that make up a DS1 signal used in T1, with each channel representing a separate phone call. Unlike the data T1 that we set up though, a voice T1 has a maximum bitrate of 56 kilobits a second per channel, and that's because it uses some of the bandwidth for control and signaling data. To integrate this data into the T1 transmission, a technique called a bit robbing or robbed bit signaling can be used. In every sixth T1 frame, the least significant bit, the 8th bit, of each of the 24 DS0 channels is robbed, meaning the value of the bit will be changed to encode signaling data. These robbed bits are used to carry information about the status of the call, such as on-hook, off-hook, or ringing. As a result, only 7 of the 8 bits are available for the actual audio data in these frames. This is no big deal for analog voice calls, but for digital data, there is a world of difference between a 1 and a 0. So for devices using robbed bit signaling, the 8th bit is simply ignored for data transmission, creating an effective bitrate calculated as 7 bits times 8,000 frames per second, which equals 56,000 bits per second. And this is why T1 channels are often referred to as 56K channels, as that is the maximum bitrate for data transfer. But telcos began offering primary rate interface service in 1988, which is a type of ISDN or Integrated Services Digital Network. While we're not going to get into the nuts and bolts of ISDN in this video, we will be covering it in a future episode, so please subscribe to the channel if you haven't to keep up to date on new releases. A PRI uses the same physical infrastructure as a standard T1, 2 sets of twisted pair wiring. There are still 24 channels, but on a PRI, 23 of the 24 channels are known as B or bearer channels, which are used for data transfer. In our case, this will be audio data from modems. The 24th channel is called the D or delta channel, which contains the control and signaling data for all of the 23 B channels. So rather than robbing a bit from each channel, the control and signaling data is all contained within the single D channel. And this gives a number of advantages. With a full 64 kilobits per second available in the D channel, there is plenty of bandwidth for additional features like dialed number identification service, automatic number identification, caller ID, and so on. And PRI was a popular choice for dial-up ISPs, as Krish explained to us.
The capacity requirements for the ISPs grew monumentally. People were willing to invest in T1 circuits or PRI circuits. The T1 circuits were actually initially were like $1,500 a month. And then when PRI came and everybody wanted a PRI connectivity to it, because that allowed you to manage things further.
And in the 90s, ISPs were constantly a part of acquisitions and mergers. So imagine the convenience if you bought another ISP across town and then could simply have that ISP's phone number moved to your PRI and then be able to identify their users when they dialed in. So given these advantages, and since we're already adept at dealing with a standard T1, we wanted to try out PRI. We'll be utilizing our Cisco IAD 2432, which is a voice over IP device that will allow us to create a PRI. The PRI will then connect to the total control, which will connect each of the 23 calls to one of the 48 modems spread across the 12 quad modem cards. And our Cisco IAD is already connected to an asterisk PBX where our Patreon users connect, and the PBX is connected to the public telephone network via a voice over IP provider. But enough theory, let's jump right in. The first thing we did was look in the documentation for steps on how to configure the Cisco IAD for PRI, but we came up empty-handed. When we tried the show controllers or show interfaces commands, the T1 interface wasn't shown at all. However, our Discord saved the day again, as this time our supporter Alfred RB came through with some crucial advice. We needed to change the card type to T1. This ended up being a fundamental step, as the card could be used for either T1 here in the US or the E1 signaling, which was the European equivalent of T1 and actually a bit faster at just over 2 megabits per second. With the type set, we next had to reload the IAD. We could then finally proceed with configuring the T1 and ISDN parameters. After configuring the required values, we then used a T1 crossover cable to connect the T1 port on the IAD to the total control. With that in place, we have a CD light on the total control, and on the IAD, we can see the circuit as up, as well as some ISDN info. With the IAD hopefully configured correctly, we can now turn our attention to the total control. For its configuration, we were advised by another one of our Patreon supporters to get the NMC card connected to our LAN, and then use remote management software by US Robotics called TC Manager. After connecting the NMC, we installed TC Manager version 8.2.6, which we found for Windows 98. To recreate the original experience, we installed it on our Dell Dimension XPS D300 that had Windows 98 installed. TC Manager was provided in a zip file, and after running through the install process, we also needed to install the Java runtime environment. With that done, we started TC Manager. In TC Manager, we have to create a new session to connect to the total control. There are several options, including an option to connect via dial-up networking. After connecting, we're suddenly greeted with an accurate graphical representation of how our total control is configured. It's actually working. We poked around a bit, and there are a huge number of parameters that can be changed for the various cards in the chassis. And of course, we had to change the LED display on the NMC. One of the things that confused us at first, though, is that there is a difference between clicking on a card versus clicking on an LED on a card. We actually couldn't access the settings we needed until we figured this out. We completed an initial configuration in TC Manager of the T1 card and looked over the modem's config. We can see the mappings of the T1 to modems, and it looks like we should be ready to make calls. So let's try it out. Upon making a test call, we just get a busy signal. After enabling some debug on the IAD, we can see a lot of ISD in detail, including an error stating invalid information element contents. Examining the settings, we noticed that the Cisco IAD was set for ISDN switch type primary-NI, while the total control has ISDN switch type NI2. These settings control which ISDN protocol is used for the D channel of the PRI. Since it seemed like this was a possible mismatch, we decided to change both sides to the AT&T 5ESS setting. The test call results in a busy signal again, and we can see from the ISDN debug that the IAD is getting further when communicating with the total control. This total control came from an abandoned ISP, and we assumed it should work. We grossly underestimated the number and just the complexity of the settings in the total control though. Even with TC Manager, it's not what you would call user-friendly, and the debug options are confusing to say the least. Their implementation of SNMP is also a pain, and we essentially gave up trying to debug. With no other recourse, we resorted to simply factory resetting random things on the total control. We also tried narrowing down the path that calls could take by routing all calls into a single modem card. And then we have success. We actually have a call connected across our PRI to the total control, albeit at 1200 bits per second, but you have to start somewhere. We also asked our Patreon supporters to help test, and we saw a successful connect of 31.2K, the highest yet. Most importantly though, our setup is actually working, demonstrating that the PRI and the total control are ready for the ISP. While we've made lots of progress, there's still a lot left to do. We wanted to delve into the net server card configuration, but that requires a separate application. We later did get a successful connection at 44K, getting tantalizingly close to our goal of 56K. We owe a huge thanks to our patrons who have been helping us out a ton, from offering advice and experience to helping test out calls and configuration changes. Please consider supporting our mission if you want to help test out the total control and further this project along. Speaking of which, on our next episode, our goal is to get multi-link PPP operational to take advantage of the huge number of modems at our disposal. Until then, thanks for watching, and we'll see you next time.